Okay, I think we're live. I believe. Let me make sure things are showing up the way I think they're showing up, and then we'll get down to business. We will get down to business. Okay, so we've got YouTube says it is live, which is good. Looks like Twitch says it's live. Let me turn off a bunch of backups and all that kind of stuff so I can save a little bit of bandwidth while I'm doing this. Okay, awesome. Good deal. So today is stream day. Get some stuff done. There we go. Awesome. Success. Cool. No, I don't want to install that. Okay, let me kick this thing up and show you what we got. So the story is that we're building this thing in 2 weeks. In just 2 weeks. And hopefully, I'm almost got this thing going. Yep, cool. Good deal. I'm gonna get this thing going too, actually. Man, I'm a mess today. I'll tell you what. I at least got my coffee. I got my coffee. That's half the battle. I do not have much anything else going on, but I got a little bit of brain left. So today we're going to start working on the graphics. And we're going to try and get that sorted out. We have it mostly functional, which is good. Let me kill this guy right here. Kapow. Good deal. And yeah, awesome. This is how the world's going to work today. Good deal. This looks good. Okay. So now we're in go mode. So we have 100% of the code that we're playing with today has been built on live stream. So you can actually go to the website in the description and look at all the old live streams, and you can see exactly how we've built everything that we built, which I think is kind of fun. And we're also trying to finish this thing in 2 weeks. So we're halfway through, I think either today, is today Monday? Yeah, so today is the start of the second half. We've spent 1 week building what we've got, and we have 1 week left. This coming Sunday is going to be the day we submit to the App Store. That's the goal. It is in 2 weeks with 100% of the code written on the live stream. We're going to have a fully functioning and fully finished game that we can send to the App Store, which I think would be a lot of fun. So we have, let me kill some of this audio in the background. I've got some stuff going on. There we go. That's better. So we have a lot of stuff built. Let me show you what we have built. I'm going to turn the engine off. We can make sticks, and sticks are just 2 endpoints that have a fixed length between them. We can make pistons, which change their length over time. So I'm going to make these immovable, so they just the physics don't affect them. And you can see the piston goes back and forth, which makes sense. We have springs, and let me make one more. Well, yes, the spring, when it falls, you can see it compresses a little bit. So it's kind of like a stick. It's unpowered. It's kind of the mix between the stick and the piston, right? The piston is powered. It pushes itself, and the spring does not. The engine, let me go like this. Let me just attach this guy down here so he stops freaking out. Now the engine is a fixed length stick with 1 point in the middle that oscillates between those 2 endpoints. So it's our second powered piece. And you can see that point kind of going back and forth there in the middle. Let's see if I can, no, I didn't grab it. There we go, I grabbed it. So you can attach pieces to it, and it can power different things. Balloons we made, those are the things that float. So they are our only anti-gravity piece. So it can pick up a little bit of stuff. If you put on too much more stuff, then it falls and floats back down to the ground. We have wheels, which are one of our combo pieces. So wheel is made out of a bunch of different sticks. But it also has obviously its circle bounding box. And so you can toss it, you can do whatever you want, you can throw these things, you can interact as they play, which I think is cool. I like the spring a lot. I think that one's really fun. But anyway, so that's what we got so far. We got lots of different pieces, which I think is pretty great. Actually, the one thing I forgot to do is let's yell at everybody that we're live. There we go. Creator Studio. So we have tons of stuff, which is pretty great. We have lots of different pieces. You can build lots of really interesting things, which I think is a lot of fun. And there we go. That's the link I wanted. So I'm really excited about it. And we're live. There we go. All right. So we have lots of different pieces and lots of different stuff that we can play with, which I think is really cool. But right now it looks pretty terrible because we're just building everything out of blue lines and red dots and stuff. So today I want to work on hopefully prettying this up a little bit. And we actually have a survey. There's a couple different options for what things can look like. I'm just going to pick an arbitrary one today to get us started. But there are a couple different graphics on the website that people can vote for if they want, and then we can implement those ideas next time. Let's look at the site and pull some graphics down, just some standard graphics. So let's go here, and then we'll fire up Photoshop. So here's the survey where we can vote on what things can look like. The graphic part style. So this is what we're going to be doing today. We're going to be looking at the wood planks and maybe the wheels. Probably not the wheels today, but we'll at least do planks and nails and stuff like that. So I just found a bunch of different vector arts for different wood textures and wood things, and we're going to go ahead and pick this guy and just use him. And then once we decide on the final graphics we're going to use, then I'll go in and actually purchase the asset. But for now, we're just going to use a stock photo thumbnail asset. And let's fire up Photoshop and get it going. The other thing we're going to look at is nails. Let me pull that graphic up. It's in Evernote somewhere. It's this guy right here. So we have a lot of different nails and oops, what happened there? Here we go. This guy. There we go. Great. Nails and screws and little connector pieces. And so today, at the start, we're going to work on rebuilding these blue lines. So they're not ugly blue lines and ugly red dots. So they actually look like wooden boards. Let's do that. That should be, I think, pretty straightforward with any luck. We're going to go there, and we're going to go, where's the other one? Did it not? Evernote? I tell you what, man. Give me my stuffs. This is super, super annoying. Save as. Can we save the image? Replace. Maybe it's just not. Oh, there it is. Yeah, there it is right there. Finally. Okay, cool. I don't know what to tell you. Cool. So here's what we're going to do. Let's do the dots first, because the dots I think will be the easiest, and then we'll do the sticks. Let's take this guy and give him a transparent background. Let's take, which one of these do we want to play with first? Let's just do the flathead, these two screws. And we'll make, yep, that's fine. We'll make two different screw types, which will be great. And now we can delete our, that's not going to work very well. Let's go here, hopefully line them up a little bit. Are those lined up? Those are, man, come on. Those are almost lined up. I'm going to say those are lined up enough. I feel like they're one off. That's as good as we're going to get. That's fine. That's fine. Fine by me. They both fit inside of there. That's good. So we're going to crop that like that, and then we're going to cut out the circle. Awesome. Actually, let's go here. I just want to crop out the circle, and then we will. There we go. Do I have to select it again? That's foolish. Oops. Let's do step forward, redo. Yep. Gosh, come on. Here we go. And then let's select this layer. We're going to kill the background. I thought we already did that. Great. And now, oops. Now let's get this background off, and we're going to have two screw heads, two nail heads that we can use. There we go. 1 and 2, right? And these are too big, but I think that'll probably be okay. I don't think I'm going to care about resolution right now. Just making sure we have at least an even canvas size, 56. That's fine. So let's save this as screw 1. Let's make it double resolution because we can. Let's save this as screw 2, double resolution. Image size 56, 28. Can I math? Can I math very good? Okay, this is screw 1. And this is screw 2. Okay, cool. So now we have some assets that we can play with. So let's pull those into our project. Screw 2. Let's copy that guy in. Let's copy screw 1 in. Awesome. Let's copy screw 2. And then let's copy screw 1 again. Okay, so here's all of our stuff. It's pretty good. Now here in our point, when we render it, we're just rendering a red dot. And instead of rendering a red dot, I would like to render one of these images that we just created. I did PHP reject. Yeah, we've been working on this for the past week. We've been doing spare parts app. Yeah, it's all open source. You can actually check out the code. The code should be in the description if you want to take a peek. We have, let's look at, I think what we're going to do is we're going to do int screw type, right? And then when this guy gets built, do we have an init method anywhere? No, we just have our regular init method. So we're going to go id init if self equals super great equals rand mod 2, right? Okay, so what this is going to let us do is this is going to let us pick between the two screw types, right? It's just going to be random. Whenever a point gets created, it's just going to pick one. and that'll be great. So now when we render down, where did our render method go? We have, here we are. So we can get our image name is going to be ns, no, we don't even need that bundle stuff. We're just going to do string with format. And it's going to be screw d.png, right? And then it's going to be screw type +1, right? That feel pretty good. And then we can actually get our dot image is going to be a UI image named image name. So now this guy should be one of those two images, and it'll be random for whatever it is. And we can do CG size of size to render, right? It's going to be a CG. Is it CG make size? CG size make. And we're going to render it in what? Just like a 10 by 10. Does that feel good? I like that. So now, if we want to render it in a 10 by 10 and we want it centered on our point, on this guy, right? CG point center. Then what we can do is we can probably do a few things. Actually, I think probably the easiest thing will be render draw. That's what I want. Draw and rect, right? Yeah, I want that guy. And so we can be CG rect make. And what we will do is we will render it at center.x minus size to render dot width divided by 2, right? And then same thing here. Oops. Size to render dot height divided by 2, and then size to render dot width and size to render dot height. And then we can not render the red dot. And I think that's all we need to do for the screw types. Let's see if that actually does what we think it's going to do. There we go. They are pretty tiny, to be perfectly fair, but I think you can see there's little gray dots there, which is pretty good. Maybe we'll make them a little bigger. 20, just so we can see them. There we go. All right. And the interesting thing is that they're always vertical. So as the thing rotates, the screws don't actually rotate. And I think we're going to be able to fix that in the next step. So let's go ahead and commit our work. Oops, let's figure out how to type. Draft, drawing screws. Next up, sticks. And of course, I use an exclamation point, which does not work. Gosh, man, I cannot type today. I tell you what. There we go. I did it. Okay. Next up, let's draw boards. So here's my thought for boards. I'm actually going to open this up this time, and we can use it to draw some stuff. Yeah, let's, do I have, yeah, I do have this guy. I do. So I'm going to just kind of talk through how I'm going to do this, so that way I actually understand what I'm going to do before I just dive into code. I want to actually translate and rotate the context that we're drawing in, and I think that's going to help us draw things in the correct perspective. Let's go to, oops, QuickTime Player. Done. New movie. from the iPad. Is that going to show? Is that going to show our thing? Yeah, it does. Okay, cool. Cool. So this is the other app that I've worked on. It's just a little sketch app that shows that lets us draw and sketch and do different things. So what I want to do and try and talk through before I jump into the code is drawing sticks. And so a stick is this point and this point, and we're currently drawing a blue line between those 2 points, right? So it looks something like that. What we want to do is we want to draw a box around that, so it's centered. Right? Does that make sense? So what I think we're going to do is we're going to, if this is P0 right here, and this is P1, then if we translate the context so that P0 maps to 0, 0, right? And then if we rotate the context so that way it becomes basically a straight line this way. Like that. So if we rotate the context, that way if we can just draw along what becomes the x-axis, then when the stick draws our two screws in the board, it's going to draw them in the rotated context. So from the user's perspective, the actual drawn visible context is those screws are going to be drawn correctly rotated. So as the board flies around the screen and rotates and zips around, the screws are going to be always aligned to the board and not always aligned to the screen. Because right now they're always aligned to the screen. Because we don't do any context muckery right here. The context muckery we're going to do in here in the sticks render method right here, right? And so I think that's the goal is we need to figure out a couple things. We need to figure out this point so we can translate that so it's 0, 0, and then we need to figure out this angle right here, which we'll call theta or whatever we'll call it. And then we can rotate the context by that angle, and then I think we're good to go. Let's try that. But before we do, let's go ahead and pull an image. We're just going to get one of these boards out of Photoshop so we can just have something to play with. Let's cut that guy out right there. Copy, and so now we have a board, right? And we're just going to call this guy, yeah, that's fine. We're just going to call this guy, oops, give me the save, board1.png. I'm not even going to care about the @2x stuff or anything else. We'll come back once we have it working and get a proper board or a few different options for a board, right? So now we have our board inside of here. So our render method and our stick, let's get our image. Our board image is going to be a UI image named board1.png is what we called it. Fantastic. We're going to do a CG float, and we're going to do board width, and we're going to have a width of 30. That might be too wide. I don't know. We'll play with that later, because right now these screws are 20 pixels. Well, they're only a 10 pixel radius and they're a 20 pixel diameter. So a board with a 30 pixel width is going to have a 5 pixel buffer on either side of these, which might be too thin, but we'll play with those ratios later. And I think a board with a 30 is fine for now. CG size. We're going to have a let's do, I think we want a self length, right? Plus board width. this is actually going to be board width and that. To size, this is going to be like drawn size, right? And the reason I'm adding board width to the length is so this right here is the board length, that's L, and then this guy right here and this guy right here sum to be the board width. So that's the extra 30. So 30 is here, and then plus whatever the length of the actual board is, right? That's the goal. And I think that's the right thing to do. And so now we can do, where's our context? We don't have the context. We can just get the current context. CG context ref curve context equals UI. There we go. Surprised I remember that. This is, I think we can do push and pop. So let's do a pop. UI graphics push. There we go. And now the push and pop, that lets us, I think we need save and restore. Actually, I think I'm using the wrong thing. Is there a save and restore begin? No. I always save context. Save. There we go. CG context save. That's what I want. I want this guy. And I want this guy. I want these two guys right here. That's what I want. So now we can translate and rotate. So context, translate our context to, what do we translate it to? We want to translate it to P0, right? Self.P0.x and self.P0.y. And if I'm not crazy, then we rotate it like that, right? And CG context rotate to atan 2f. I believe that gives us the angle, if I'm not crazy. P1.x minus self.P0.x and self.P1.y, self.P0.y. See float angle. Let's just save it out here. Angle. It does what I think it does, doesn't it? Yeah, it gives us a float. Okay. I think that's what we want. And now if we rotate it, now we should be able to draw from now we should be able to draw from 0, 0. Let's actually we're just going to undo that. So we should be able to draw from 0, 0 to the length of the line along the x-axis, I think. And that's what we're just going to test that right now. Move to point, CG point 0, great, and new line, add line to point, CG point make, self length, and 0, and then new line dot width, line width, we're going to make it super wide, and then what's our fill color? UI color blue, set fill, and then new line fill. Let's just see if that does what we think it's going to do in a very general way. And then we'll come back, and as long as we're drawing in the right place, then we can swap it out and start drawing the image instead. Right? Does that sound good? I think that sounds right. Let's go here. That is not at all drawing where we thought it would be. Okay. So why not? if we don't rotate by the angle, then we should always draw from 0 to 0. Can we at least do that? No, we can't do that. So that means our translation is probably wrong. Can we do that? This is my guess, test, revise method. No, we can't. Self.p0, right? We are at just in a regular place. You know what I'm going to try to do? I think the save and restore should do it, but just to overcode stuff, we're going to unrotate and untranslate all the time. That still doesn't do it. I always get it backwards, which way is plus and which way is minus for the translation stuff. So I think, man, I do this every single time, but it's still not doing anything. If we don't translate, if we don't do anything, if all we're doing is drawing a line, then we should see it in the top left corner, and we don't even see that. Is my length 0 for some reason? Doesn't make any sense. We should be seeing at least something. Self length, right? The length is 100. We are filling our new line is from 0, 0 to 100, 0. So we should be in the top left corner. Line width. Oh, you know why? Oh my gosh. I tell you what, man. I tell you what. Sometimes it's the dumbest things that that get you. We just have to stroke instead of fill. Yeah, so now it's way up there, right? Now we're doing the right thing. So now we can translate like we wanted to. Let's try and not do this and see if that fixes what we think it does. Yep. Translate there. Yeah, there we go. So now it's drawing in the correct x at the correct starting point. See, when I start the line, it starts at the right spot, and it's just not rotating. So now let's fix the rotation right there. Let's see if we're rotating the correct direction. We might be rotating backwards, which I am. Looks like we're doing. Oh no, that did pretty good. Yeah, it is rotating backwards. That's pretty great. So if we rotate by negative angle, let's see what we do. Now we're just, are we always 90 degrees off? Yeah, we're always 90 degrees off. So now if we rotate by angle, plus m pi over 2, right? There we go. Look at that. Now we're drawing sticks in the right place. That's good. It's good news. Good news. So now what we need to do, what do we need to do? Now we need to draw our board image. Let's try and do that. All right, so instead of drawing here, let's do draw and rect, cg rect make. This is going to be What's our board width, did we decide? Negative board width over 2. The y is negative board width over 2. Our width is self.length, and our height is board width. Does that feels correct? We'll put the blue above it just in case it doesn't draw quite correctly. We can see where the blue is drawing and where it needs to be. And then we'll kill that guy right there. Awesome. And now I think that will draw our image. Yeah, look at that. Now we have little boards. Here's our stick, our blue. Our width is, we did not quite right. We need to do plus the board width, which we had talked about. Right? What are your thoughts on Swift versus Objective-C? Any good suggestions on learning Objective-C? I know it doesn't really have... I know it decently, but I haven't really produced any apps. So when I learned... See, that's pretty good. That's a pretty good little board, right? And now we have our little box, which looks kind of boxy. It's pretty great. I like that a lot. So when I first got started with Objective-C, I actually read a book. I wish I could remember which one it was, but the book helped a fair bit. The things that were tough for me was figuring out the delegate pattern and figuring out what Apple meant when they meant MVC, because every MVC I've ever seen ends up being a little bit different for whatever reason. Everyone just does their model view controllers a little bit different. I would actually suggest downloading a bunch of Apple's sample code and trying that, and then just poking with it and changing how their sample code works. That's a lot of fun. Let's see what the wheel looks like. The wheel looks ridiculous. Looks absolutely ridiculous. That actually, honestly, looks better than I thought it would. Yeah, we can actually do some... That looks a lot better than I thought it would. Why can I not pick it up? Let me pick it up. Oh, because I'm making new wheels all of the time. Now there are a billion wheels there. Yeah, I would download Apple sample code and start playing with that, because they have lots of good stuff, and it's that's how I learn the best. Is I learn by tinkering with somebody else's code and trying to make it do something else. Get my empty coffee cup out of the way. Okay, so now we have boards doing okay. So now if we also try and render the points, let's see what happens, right? The points here, if we render outside of our space, then they still rotate with the context, right? They still rotate and are aligned to the screen. And that's not what we want, because, or that's what we expect, because we're restoring the context before we draw. But if we render before, then we're still going to have a different problem. They're now going to be aligned to the board, but they're, if I bring them all the way back here, then they're a little bit better. Now they rotate with the board, which is nice, but you can see they're going crazy. And they're going crazy because we're rendering the board from 0, 0. We're drawing it from 0, 0 to the length, right? And these points are rendering at wherever their point is, here. So what we need to do is we need a better way. What we might do is... we can do a couple different things. We can add a different render method. We can have these points render... We could have them render always at 0, 0. That would probably be okay. So if we did, let's kill this old code, because now we have our dot method. Let's do render at 0, 0. And now what we're going to do is we're going to steal some of our context code here, right? So now our render method is going to be translate by self.x and self.y. and then we're going to call self render at 0, 0. And then CG context restore context. Right? Is that what we do? Yeah. Yeah. So functionally, this method is the same as it used to be, right? So given a context without anything, without any translations or rotations or anything, it's just going to render it at its point, and it's going to do that here. So now the center is at CG point G.00, and it's going to render itself at point 0, 0, which is what we want. So here we can render P0, and then we need to translate once more. We're going to translate self.length here and Y0, and then we can render the second point. All right, so you see what I'm doing? So we're rendering the board where the board starts at 0, 0, and we're giving a bit of a buffer. And then its length lies along the x-axis. Then we render our first screw in the board at point 0, which is correct because that's where we're starting our board. Then we're translating the context again along the length. So now our endpoint is at 0, 0, and now we render the endpoint at 0, 0. And then we restore our context. So this needs to be, instead of render, we want render at 0, 0. Render. There we go. Render at 0, 0, and render at 0, 0. So now our points should be aligned to the board as it flies. Yeah, and you can see that they rotate as we rotate our graphic. Those screws also rotate, which is pretty good, right? I like that. Bonk, bonk. Awesome. Oh yeah, let's add our README as well. I did a simple README. Git commit. Render points and sticks. Pretty great. There we go. Cool. I like that. Now a couple things we can also do is boards. You can see when it clips at the bottom to 0, 0. Let's fix that so that way the board rests kind of on the inside. That should be a pretty easy thing. So that way the board doesn't kind of half fall out of the screen. I think we can do that here at, is it constrained points? I believe it is. Yeah. We don't have a constrain. We have an update sticks. Sticks constrain. But this just constrains the length of the stick, and we want to constrain it to be inside of the screen, which is in here. So what we're actually going to do, because we're starting to get lots of different widths and whatever else, is we're going to make a constants file. So we can, come on, what happened there? What on earth happened there? All right, that's fine. Constants will actually change you to be, there we go, and we'll go define stick width, and that's going to be, our stick width is 30, and we're going to define point radius is currently 10, I believe, right? Revert. Oh, frustrating. Define stick width. Let's try again. And a define of point radius is 10, because we currently had it defined as the diameter. So now if we go in here, we can go to sticks in the render method. We don't have to render our blue line anymore, which is great. Our board width is now our constant. So our board width is a constant. Let's actually change this. We'll rename it to something k-stick width, which would be a little bit more consistent with how people define. Oh, come on now. K-stick width and k point radius. There we go. That's fine. So stick width. There we go. There we go. That is a little bit better. Do we not use? Yeah, we apparently don't use U anywhere. Drawn size. We don't use U anywhere. Draw our board image. Render our nails or screws, however we want to call those guys. And then we're done. Awesome. And we can get rid of this code. Awesome. Cool. That looks great. And so then in our points, we wanted to render, what do we call it? Yeah. Draw rect. This guy, k point width. But we need to import, again, our constants file. So now we can render k point width, k point radius. Oops, sorry. Times 2. Times 2. Great. Awesome. Right, so that's pretty good. So now what do? We just did a little bit of cleanup. So our balloon looks kind of ridiculous because it has a nail in the middle of it with a green line. So maybe we'll update that. Our wheel looks better than I thought it would, but still looks a little bit awkward. Our engine looks a little bit strange. Let's go here, make it immovable. Let's go here, make it immovable. Turn it on. Yeah, look at that, because we stretch the boards to fit whatever their width is. So our engine looks kind of weird. Our piston probably also looks a little bit weird because it's just the board stretching back and forth. And our spring is also going to look a little bit weird as it hits the floor. It's going to compress the board a little bit, right? Is it compressing the board? Or is it just clipping the board? Anyway, doesn't matter. Doesn't matter, because all those are wrong. So let's commit our code. Oops, a bit of cleanup. So what should we fix next? Do we want to fix wheels? Oh, we're going to fix the constraints on the board. So that's what we wanted to do, and that's what got us on our little tangent. So if we constrain points, then we actually want to constrain to the size. Let's import our constants file again. There we go. And constrain points. Here we go. And we want to constrain these into stick. Yeah, k-stick width divided by 2, right? We want to constrain them to be inside of the stick. There we go. And then it needs to be a little bit greater than 0. Greater than 0. So now when we drop our boards, they should actually stay inside of the screen. Yeah, great. So now our board stays inside of the screen like it should. Right? Does it? Yeah, that's fine. Cool. That looks a lot better. Cool. I think it still clips maybe a little bit when it's diagonal. Does it? No, it does okay. It does the right thing. Yeah, okay, cool. Awesome. Awesome. So that's a really easy one. Fix the clipping on the edge, which is pretty great. So what's the next thing that we want to render a little bit better? Do we say we can probably do wheels and get wheels to look not terrible, right? So if we can do that by clipping on our balloon path, right? So if we take our balloon and we can do add clip, I believe that's what we want. And then if we want to save and restore our context as well, we save, and then if we restore, this is funny that we're calling it a balloon even though it's a wheel. Doesn't make any sense. I guess we built balloons before we built wheels, so we shared a little bit of the code. That's fine. Right, so now in theory what should happen is we take the radius of our wheel, we clip the circle so we only draw inside of the circle, we render everything just like we were. We don't need to actually draw the blue line, and then we restore our context. So now wheels should look better. They won't look perfect, but they won't look ridiculous. Yeah, now they actually at least look like a circle, right? So that's something. And man, our rendering code is a nightmare. It's an absolute nightmare. Now we're getting some frame drop. Pretty terrible. Things are slowing down. That's probably that's okay for now. We're gonna optimize later. We just want things to render moderately correctly. Okay, so what's next? What's the next thing we want to do? I think the next thing we want to do is we might want our wheels to look a little bit better. We have a couple options. We can make pistons look better. We can make springs look better. I don't have a graphic for springs though. That sure looks like it like it's not compressing like I thought it would. Yeah, it's not. Springs are not rendered correctly. So springs we need to fix a little bit. Okay, so the ideal length is len, so we want calclen for the stick instead of length for the stick, which is here. Can we do that? Yeah. So when we calculate our length, this gets our length immediately right now, as opposed to our length method, which gets our idealized length, our length without stress, I believe. There we go. So now when we create a spring, yeah, it does a little bit better. Our stick. Our stick when we render, it's still not quite right. What did we do wrong? I think that's part of what we did wrong. Yeah, because, oops, I want the move point tool, please. Yeah, because things are, the points don't line up, and if the points lined up, then I think we'd be okay. And the reason they don't is because we were still translating by length, and so now I think our points will line up correctly. Right? So that looks pretty good. Now if we have a spring, there we go. That looks better. Our piston probably looks a little bit better. Yeah, that's fine. They're at least doing the right thing now, which is what we want. So let's make, we can make piston graphics or we can make wheel graphics. What do we want to do? I think we want to do wheels a little bit because the wheels need the most work. So let's actually go to the wheel, and I want to show, our blue line again. let's do that. So the problem with wheels is that the wheel shows our blue line. Yeah, it shows our blue line. So our it's kind of hard to see the blue line, but basically the point centers are on the very, very edge of the wheel. And what we want is we want the center point, which is currently not showing up. We want that center point to show up. We also want the points centers to be the point radius width away from the blue line, right? So that way they actually show up inside of the wheel a little bit instead of on the edge of the wheel. And so I think what we want to do is we want the radius, when we create our radius, these are plus or minus the radius. So when we create wheels, I think we want to give them a bigger radius than we do. We have a hard-coded radius. So let's add that to our constants. We're going to give our wheel radius a little bit bigger. And let's make our wheel radius 60. Right? So it's a larger radius than it used to be, which is fine. So now in our wheel, we want here, this is just adding the points to be the radius, away, and instead we want it to be radius plus k point. Oh, come on, did I not? Maybe I don't have the constants imported like I thought I did. Great. K point radius and minus point radius for 2 and for 3. And here, same thing. So now let's look at what that does. I think that's going to give us our points inside of the boundaries of our wheel. It did not. And it did not because I always get that mixed up. P3.y, P0.x. Oops, sorry, P0.x, great. And then P1.x. I think that's what I wanted. They're still right on the edge of our radius, which I did not entirely expect. So why would that be? Why would that be? Wheel is larger than it used to be, which is good. We have Does that make sense to anybody? Because I just added this radius here. Right? Am I crazy? Let's put this back to the way it was and put this back to the way it was. Minus equal. Minus, right? And then P3.y plus, right? Yep. I'm fixing those to be correct. These minus equals always throw me off, so I just want to get rid of them. Minus, and then this guy is going to be a plus, right? So now our points should be centered on the very, very edge of the wheel, which they are. And now I want the points to be moved inward a little bit. Okay, point radius. Okay, point radius. So now 2 of the points should be inside of the wheel. And they're not. They're, what, are they further outside of the wheel? Am I pushing them in the wrong direction? That doesn't make any sense to me. My brain is not, yeah, they were being pushed the wrong direction, but I don't understand. I don't understand why. So we get the center. We subtract the radius of the wheel, which moves it further left. All right, so part of the issue, it appears, because now that all I did was I changed these 2 points, and now suddenly the points that were inside of the wheel are now back at the edge of the wheel. So somewhere I am saving the radius. This radius needs to be saved as our radius, right? I think that's part of the problem. We were recalculating the radius. Yeah, so now they are outside, which I would expect them to be if I'm doubling up the signs there, because I want to move the points the opposite direction. There. Now I think we're playing baseball. Now this is, yeah, now we're doing the right thing. Cool. Cool. So now our points are all inside of the wheel, which is what we wanted. And it's still, I believe, if I set it down on the ground, it's still resting on the edge of the wheel, which is what we wanted to be resting on. Okay, cool. Great. I might also want a little bit of a buffer, because now those nails are like right on the edge of the wheel, but I don't care. Let's pull out a random wheel graphic from our options. Let's get this wheel maybe. That looks pretty fun. If I save this into here, oh, there it is right there. Great. Let's go here to Photoshop. Let's crop this wheel out. Yeah, that's fine. Great. Great, great, great. There we go. Crop. Select inverse image crop. Image crop. Why didn't you crop? I don't understand why you didn't do what I wanted you to do. That's pretty good. That's pretty good. There we go. That feels better. And now, yep, and yep. We'll crop those, and now we can actually cut out the background. The white background. Let's do that. There we go. Select inverse cut. Cool. Great. Again, we're just going to use this graphic for now. It obviously has the watermark on it. I haven't decided on what the final assets are going to be. You can actually go to the website, the sparepartsapp.com, and vote on which assets you think would be a really good fit for the game, which would be pretty awesome. So yeah, so go check out the website and tell me what assets you want to use. And the next stream, hopefully I will have all of decided, and we can figure it out, and then I'll buy the assets and we'll use those, right? Cool. Awesome. Awesome. Okay, so now on our wheel, when we render the wheel, we can go ahead and render that background. So we're going to do something similar that we did for sticks. We're going to take our context, we're going to save it, we're going to translate it, and we're going to rotate it. Where is our, here we go, in our render method. So we have our clip, that's fine. I'm going to go here. We got current context. What are you angry about? Oh, because we already did that right up here. That's fine. Delete that. We're not going to render our sticks, and we're not going to render our original crossbar either. We are going to rotate. We're going to translate to P0. We want to translate to our center, not to, we're going to do that. There we go. And so then our angle, dot Y, awesome. Okay, so now we're rotated here, and we can actually go to, we can fetch our image of our wheel image. Image named wheel.png, right? And we can draw in our rect, CG rect make, negative radius, and radius times 2, and radius times 2, and I think that will just work. That'd be amazing if it did. Don't you think? Cool. And we can do yeah, we're not going to render any of our points right now. We will in a minute, but we're not going to do that right now. But we can render our center point. Do we have a center point? Yeah, our crossbar, which is P0, P1, P2 is probably our center. Yep, it is. No, it's not. So what's our center point? We have 0, 1, 2, 3. So these have a radius added to them, so they're on one edge. P2 and P3 are on the other edge. Spoke 4 is center. Oh, our center is an mm point. Yeah, so our center is called, strangely enough, center. Render 0, 0, right? Because we just translated to 0, 0. So let's see if that does what I think it's going to do. Now when we make a wheel, we should have a wheel image with a screw right in the middle. Yeah, pretty good. Awesome, that's kind of nice looking. So now we need to render the other two screws, or sorry, the other 4 at their respective locations. So we're actually going to save again. We're going to save and restore. We're going to translate at each point. We're going to translate x. So our x, our plus x, plus radius x is point what? Point 1 is plus radius, and point 0 is minus radius, right? So for plus radius is point 1, we said. Oops. Come on now, self.p1. Render it 0, 0. And p0, oops, p0 is at minus radius on the x-axis. And we're going to do this again for P2 and P3. So P2 is on the y. P2 is y minus radius, and P3 is plus radius. So 2. P3 is minus y radius, and P3 is plus y radius, right? So now we should have all 4 on the wheel. We draw, and all 4 of our things work. Oh yeah, and I forgot, because we have our point, right? Plus, minus, plus, minus. So now they'll actually be centered at the correct place. There we go. And so now if we take a stick, we can attach it to that part of the wheel, and it actually looks like it's at the right spot. There's our crazy contraption machine, which is starting to look correct. And it's starting to actually look like something, which is kind of fun. That's pretty fun. Cool. So another thing I wanted to look at is if we make that guy immovable, we make this guy immovable, if we make this guy immovable, and if we make a piston between them, then that piston should break, I think. Yep, and it falls apart into a bunch of different pieces. Cool. That's pretty awesome. So now the things that we don't have yet are like our engine. Looks pretty awkward still. Our spring looks like a board, which doesn't make any sense. And our piston also doesn't make any sense. It looks like a contracting board. So maybe we'll make a piston next, right? Let's go ahead and commit that. Wheel looks sort of like a wheel. There we go. So now what do we want to do? Now we want to do, maybe we will work on our engine, right? Would that be good? Yeah, or a piston. Our piston's probably a little bit easier to draw than our engine. So let's draw some piston stuff. Let's go to Evernote. That's what I was looking for, to figure out our kind of metally looking textures. We can get this guy, and we can make something out of him. There we go, this guy. Okay. So we're going to make our piston out of this stuff, I think. Not out of that, we want it out of that. So the base of our piston is going to look like this stuff, I think. Yep, so let's give it a little bit more buffer. It'll look like that. We'll actually erase some of these. Scale, take some of those dots and take those away. And then we can make it, how wide is it here? 11. I think it's probably around there. Is that what we decided? Crop. So that'll be the base of our piston. Yep, pretty good. So let's save that as our piston base. And this texture here will be our piston head. Copy, oops, copy. Oh, actually, let's go. We can take the background off. No, that's fine. Yeah, we're just gonna do this. Piston head. All right, cool. So now let's import those graphics as just fill-in graphics until we decide what our final graphics are. You can look on the website. There's a place where you can vote. If you care, you can vote. And you can tell me which graphics you think would be cool. So here, the length oscillates from basically plus or minus 0.6, right? So it goes from 0.6 is our base, and 1.0 is our of our super length is our actual length. So let's go to our render method. We're gonna copy from here, go to our piston. Here we go. We want self and self. We're going to import our constants file. So now, if P0 is at 0, 0, which is what we want. So instead of board image, we want piston base. Isn't that what we called it? Yep. To self length times 0.6, right? Yep, that's what we want. What are you angry about? Angle. Oh, angle hides instance variable. Yeah, so we'll call it rotation. Because angle, this is not really descriptive of what's going on. That's the extension of the thing. Okay, so now we want this is our base image, and we want our piston head image. So that just should be super, by the way, because we want our fully extended length. So that starts here. And it extends to self length, length minus where we started. So I think that's what we want. So we want to draw our head and then render P0, and then we go to self length to 0, 0. That feels right. Let's see what happens. Let's see how we do. So now when we make, let's turn animations off. You're removable and you're removable. So we make a piston here. That looks surprisingly bad. But let's see what happens when we turn animation on. Interesting. Oh, you know why it looks particularly terrible? It looks particularly terrible because these guys are vertical and we're drawing horizontal, right? So we just need to go in here. We can rotate, and we'll go here. We will rotate. Awesome. Awesome. Let's restart and see if that should draw it a little bit nicer. Maybe not super nice. That looks better. Right? That looks pretty good. But one thing is if we have a stick, it's movable, it's movable. This guy I think is going to snap. I think that point that we're drawing, I think we're drawing it in the wrong place. Pretty sure, but maybe that's right. Man, it sure doesn't feel like it. But I guess so. That's fine. All right. It really feels like it should be further down. I think what we're actually doing is we're drawing. I think we're drawing this guy too long. I don't think we need to draw him that long, and that's part of the issue. Yeah. Well, okay, stick width. I think that was the issue. Is we should have been dividing by 2 because we only need half of the extra length there at the bottom. Did I put that in the right place? Yeah. Yeah. So our piston. Yeah, that's right. Right. So now it's at the right spot. And because the screw's kind of going over the base a little bit, we want 2 times point radius. So you're going to start a little bit sooner, and you are going to end a little bit sooner. There we go, that's great. And now that means your width, since you're starting sooner, X, Y, you need to be longer. All right, does that make sense? So that way now we're actually drawing it. Oops. There we go. That's fine. All right. It's a little better. And our board draws from negative to 0.6 plus stick width minus 2 point radius, base image, that's fine. I don't understand why this is showing the wrong texture up here, up near that point. That doesn't make sense to me. I don't know. I don't know. Doop. Great. But now it looks at least sort of okay. We're going to make this guy a little bit thinner as well. So he goes X, Y. Let's add some line breaks in here so we can make a little bit more sense of it. Let's just do like -4. And this is going to be +2. So that way it's not exactly the same width all along the piston. All right, there's just a little bit different width, and so that gives you something interesting. Cool. So now we need what? Spring, I don't even have sample graphics for. Our balloon still looks ridiculous. And our engine still looks like ridiculous. Not entirely sure what our engine should look like, to be honest. No idea. What if we made the engine look like what if we cut out a little bit of this right here, like that, and this is going to be our engine back. And then if I do, how wide is this guy? I think we said he was 11 pixels wide. No, he's 31 by 31, right? And we're going to fill that with this texture here. 31 by 31. There we go. Oh, I don't need you anymore. Put you there. And then this is going to be like that. Transform. There we go. And then here, we'll do the same thing. These will be the endpoints. Oh, that looks terrible. Copy merge. Let's paste that. Scale. Make it a little bit taller, and then move it down here, like that. Right? This will be the engine edge, engine end. Right? Okay, so let's go here. We've got our engine and our other engine back. There we go. So then when we render this guy, let's go steal some code from that so we get our context the way we want it to be. Like that. We don't want to render any boards. We're going to get our graphics are going to be the engine end and the engine back, right? Engine back. Oops. Engine back. That's what we called it, if I'm not crazy. Yep. And then our engine end. Right? Yep. Okay, cool. So our background for the engine, this is going to be like our little track. Engine back. That's going to be the track along which these guys slide. So we need to import our constants file. Okay. Okay. He is going to be rendered at the starting point. This is engine end, sorry. In a square. And then we're going to translate to the very end and render another square at the end. Right? And then we also need to render P P2, which is going to be pistons P1, right? Yeah, self.p2, yeah. So we go to, we translated. Let's restore and save and restore again. Oops. Yeah, no, that was right. And so now we can translate to P2's location and render it. Self.p2. Actually, we want the distance of the piston. We want the piston's length. Right? And now we can render P2. Awesome. And another one of these. Awesome. So I think that's gonna give us something, you know, very moderately engine-y looking. That looks awful. Engine end. Did I not do what I think I did? Yep. Just engine back. Oh, that's why, because we did the exact same thing we did with the pistons, where things are rotated wrong. Let's take this guy, and we're going to need to rotate him to his side. Rotate right. Right? So now we should have a track that... No, come on. Here we go. Now it slides back and forth. Great. Oh, it broke. Yeah, that's fine. Engine, that, movable, movable, piston, like that, and then a stick, like that. And it broke. Oh no! Maybe a spring. Will a spring work? Yeah, spring works, kind of. Yep, anyway. That's getting us a little bit closer. We have wheels. Yeah, the graphics are bad. They're definitely bad, but we at least have it drawing moderately consistently. So the one thing that I want to fix, you can see here, these two are not at the same place. I need to decide how to render this engine so that way it, when we make an engine and we turn it on, this guy looks like it's exactly on the track, but in truth he's not. He's not 100% on the track. You can see him wobble back and forth. And our old blue line and red dot rendering had it. It was obvious where that wobble came from. So we need to fix that so that way it renders a little bit better. But this is something. So we could do springs. I don't even have an almost graphics for springs. We could also do, when we draw a piston, it's currently drawing a log and then it snaps into a piston. Let's fix that so it actually draws what we think it's drawing. So create piston gesture. Our piston. Currently edited stick is a piston. And currently edited stick is a piston. So now I think when we draw, it should draw a piston as we drag it. Yes, it does. Dink. There we go. Great. Let's do the same thing with an engine. Let's do create engine. Engine with P0. And oops, let's do engine with P0. Engine, please. It is freaking out. What's the matter here? We have start point is an X and a Y. We have current location is an X and a Y. Is it because they're the same place? 252, 178, 252, 178. Yep. Yep. Engine length is 0. So if we don't have a length, then percent length is 0. That's fine. There we go. So now we have now we can make an engine, which is great. Awesome. That's something. And we can connect them up to stuff. Who knows what's going to happen there. That looks ridiculous. That's pretty fun. I like that. Our graphics still aren't great, but that's okay. The point is that we're trying to get it so it draws something. And then over the next couple days, we'll actually get the final graphics. I haven't even bought these assets yet. So once we figure out which graphics in particular we're going to use, then I will buy them and we will chop them up and we'll make them a little bit more pretty. Like that engine graphic is not very nice. The piston graphic is awkward because it stretches, but that's okay. We at least got it drawing something. Our wheel I think looks okay. The one thing we haven't been able to do today is the balloon and the spring. Right? Those are the two that I don't even have the beginnings of graphics for. So I'll look and I'll try to find some graphics soon. There are already a couple different options for what we can do for the wood on the sticks and the metal textures and the wheels and that kind of thing. So if you want to look at sparepartsapp.com, so it's in the description. And then if you go to, there's a place here for a survey. What should it look like? There is, it shows all of the different options on what we can use for different textures for the wood and different textures for the wheels and stuff. So if you want to check that out, that would be cool, and give me your advice on what you think we should use. And then I will buy those finalized assets and set it up. The other thing is, if you would like to get on the beta list, I'm going to set up iTunes Connect this evening and send out builds to anybody who's interested, so we can actually start getting it on your device before you submit, hopefully this coming Sunday. So there's a lot to do between now and Sunday. We need to finalize the graphics and finalize the drawing. We need to change the interface because this button interface is pretty terrible, so we need to make it a little bit better. We might also do, like right now you can select, when you click on a point, you can make it immovable or not. We might also do that for sticks, so that way you can change pistons, and you can change, right now it just goes back and forth by that 40%. And same for engines. Engines are always, they go the full width. So we might actually make some properties for different types of pieces. So that way the engine can just oscillate between, 70 and 80% or 20 and 50% or whatever. Same thing for pistons. We can try a couple different things. But anyways, give me your thoughts. Check out the website and follow on Twitter or whatever. I would love for you to check out the survey and give me your thoughts on what textures we should use, and then we can use I'll chop those up this evening or tomorrow morning, and we can implement real life textures, our finalized textures, tomorrow, and start working on our final user interface. It also probably needs a nice background too, so I might try and poke around and find a couple options for a background for it. But yeah, we've got to send contraptions to other people. So if your friends have the app, then you can like email or text your creation to them, and then they can load up your creation in their app. I think that would be cool. But anyways, yeah, thanks for coming out. Thanks for checking it out. Did we commit everything? Are we up to date? No, we're not up to date. Commit. Drag new parts shows correct texture. Great. Git push. So all the code's up online. You can check it out if you want to. It's right there. It's on screen. It should be in the description. And I will see you guys tomorrow. We will do it again and figure out what our next step is. But yeah, please do go check out the site and tell me what textures to use, and then I can get that 100% finalized. Thanks guys for coming out, and I will see you tomorrow. All right.